Let's get right into it. We're not talking about the AI that just writes poems or summarizes articles anymore. Today, we're diving into AI that acts. This is all about Agentic AI, and let me tell you, it brings a whole new class of safety challenges to the table. Ones that pop up the second an AI can make its own decisions and take action in the real world. So, to really get a handle on how big this shift is, let's start with a simple comparison. You've got your standard generative AI, right? The kind we're all getting used to. You can feed it mountains of medical data, and it can spit out what looks like a perfect medical diagnosis. I mean, the language is right, the structure is professional, but the conclusion? It could be completely, dangerously wrong. We call this misinformation. It's a huge problem, for sure, but right now, it's still just words on a screen.
Okay, now, let's give that same AI the power of agency. Suddenly, it doesn't just write the wrong diagnosis, it acts on it. It can go into a pharmacy system and order the wrong medication. It can schedule the wrong treatment on a hospital's calendar. That error, which was just text a second ago, has now become a real-world action with potentially devastating consequences. And this is so critical to understand. This isn't just about the problem getting bigger. It's a totally different kind of problem. We've moved beyond just worrying about the quality of content an AI creates. Now we have to manage the consequences of its conduct, and that requires us to completely rethink how we approach AI safety. This slide just lays it out so clearly. On the one hand, you have generative AI, the creator. Its whole world is making content, and its biggest risk is misinformation, getting the content wrong. But on the other side, you have Agentic AI, the actor. This thing makes plans, it has goals, it makes decisions. And its risk? It's all about misconduct, taking the wrong actions. It's the difference between an AI writing a bad business plan versus an AI autonomously making a series of terrible financial trades based on that bad plan.
So, what's powering all this? Well, at the very heart of it all are large language models, or LLMs. Think of an LLM as the foundational brain. It's a massive, super complex model that's been trained on just an unbelievable amount of data from the internet. This brain is the engine that drives both the creator AI and the actor AI. But an agentic system, that's something more. It's a whole framework built on top of that LLM brain. It's not just about coming up with a good response. No, this system is designed to look at a situation, figure out a multi-step plan to achieve a goal, and then actually do it using whatever digital tools it has access to. It essentially has intent.
And that brings us to the single most important takeaway from this whole discussion. And it's captured perfectly in this quote. The very instant you give an AI the ability to act, what we call agency, its mistakes transform. A simple error, a piece of misinformation, it metastasizes. It becomes active misconduct because the system doesn't just say the wrong thing, it does something based on that wrong thing. So how do these things actually break? Well, as a safety engineer, my first instinct is to look inside the machine. And one of the most critical failure points is internal. It's when the agent's own thought process, what we call its reasoning chain, gets corrupted. See, every agentic AI runs on this basic loop. First, it analyzes the situation with whatever data it has. Second, it formulates a strategy to reach its goal. And third, it executes that strategy. That whole sequence is the reasoning chain. And every single link in that chain is a place where things can go catastrophically wrong. Okay, the first major internal threat is what we call an adversarial attack. This is when a bad actor crafts a very specific, tricky input, maybe a piece of text or an image, that's designed to fool the AI. It's not like a password, it's more like an optical illusion for the AI's mind. A person might not notice anything wrong, but for the model, it triggers a hidden weakness and causes it to completely bypass its safety rules.
And here's where it gets really scary. An adversarial attack doesn't just make the AI say something weird, it can actually hijack its entire planning process. It corrupts that formulate strategy step. For example, a hidden prompt could trick a supply chain agent into thinking there's a huge demand for something useless, causing it to order millions of units. Or it could fool a trading agent into dumping a valuable stock by feeding it cleverly disguised fake news. The agent's own drive to achieve its goal gets turned against it. The second internal failure is, in some ways, even scarier: hallucinations. This is when the AI just makes stuff up. It states something that is completely, totally false with all the confidence of a textbook. It's not just getting a detail wrong, it's a pure fabrication that the model believes is 100% true. Now, for an agent, this is uniquely dangerous because one single hallucinated fact can poison the entire reasoning chain right from the start. If a medical agent hallucinates that a toxic chemical is a safe ingredient during its analyze situation step, well, every single thing it does after that, the strategy it creates, the actions it takes, will be based on that lie. It will then pursue a deadly, flawed plan with perfect, unwavering logic. So we've looked at the technical problems inside the machine, but that's only half the story. To really get the external crisis this is creating, I'm going to bring in our legal tech strategist. Thanks. Yeah, as a legal strategist, I see a totally different crisis brewing. It's not in the code, it's a fundamental breakdown of our laws around who owns what, intellectual property. This right here is the question that our entire legal system is just not ready for. I mean, think about it. When an autonomous agent designs a new car part, or writes a piece of code, or composes music, who owns it? Who gets the patent or the copyright? Is it the company that built the AI? The person who gave it the initial goal? Or are we walking into a new world where the AI itself has some kind of claim? We just don't have the answers.
To even start to sort this out, we need to get serious about a concept called provenance. Provenance is basically the digital paper trail. It's the verified, unchangeable record of where an idea or a piece of content came from. Without a foolproof way to prove whether an AI came up with an idea on its own or just stitched it together from copyrighted data it was trained on, well, our whole system of IP law just stops working. And this new reality is forcing a massive change in strategy. The old way to protect your IP was all about detection. You'd wait for somebody to steal your stuff, then you'd have the lawyer send a nasty letter. But with agents that can create and use thousands of pieces of content per minute, that approach is just way too slow. The new model has to be prevention. Suddenly, IP compliance isn't just a problem for the legal department anymore, it's a real-time, automated, technical problem. So if IP protection is now a technical problem, then we're going to need technical solutions. And the response that's starting to take shape is pretty wild. We're basically being forced to build automated systems to manage the legal risks created by other automated systems. Here are a few of the key technologies that are really paving the way. People are using blockchain to create these unchangeable records to track the provenance of AI content. We have automated systems that can check in a fraction of a second if an agent actually has the right license to use a photo or a data set. But the most radical idea is the third one on this list.
And that is the audit agent. You heard that right. We are literally building AI to police other AI. These are specialized agents whose only job is to watch over other autonomous systems as they work. They check every single thing the other agent creates or does against a huge database of copyrighted material and licensing rules to stop a violation before it even happens.
Which leaves us with this final, really tricky thought. We're building all these sophisticated technical guardrails to manage AI behavior. But what happens when the guardrails themselves fail? If one of these audit agents messes up and lets a huge copyright infringement slip through, who's on the hook legally? And from an engineering standpoint, how do you even build a system that can reliably audit another system that might be just as complex or even more complex than itself? It just throws us right back to these deep legal and ethical questions. It seems like for every technical solution we come up with, an even bigger challenge for society pops up right behind.